All right, so we're in section 6.5.3, the related Sage code. All right, so just going through it again, I hate to say a lot of redundancy in what we're doing over here. And not that you have to watch these things, but we're hoping that redundancy, you start to realize that there's options that you could be taking, including reading, not watching. And let's take a look at the solve. And let's see, it says, looks like x cubed, right? Minus, whoops, 3 times the floor. That's a built-in function in Sage. It's used in computer science a lot. It equals 4. And they want you to solve for the variable x. What happens? Well, it really doesn't appear to be much happened over there. I mean, it looks pretty complicated, actually. All right? So what I want to do is plot. And we'll go back over this to make sure you understand what we're talking about over here. And it looks like we're going to plot a list. And the list we're going to plot is x cubed minus 3 star floor x, and we're going to plot the number 4. That means y equals 4. There's two functions we're plotting. Y equals 4 and y equals x cubed minus 3 times the floor of x. And we're going to do x min. We're going to set that to minus 2.5. And I'm going to go back over the notes and explain why we're doing that. And x max is 2.5. All right, graphed it out. Now I'm kind of looking at it, kind of crazy looking. I want to point out there are what's known as artifacts in the problem, and I want to point out what these artifacts are. If you look at these vertical lines over here, these are not supposed to be there. What is it doing though? Sage is computing a bunch of points and it's connecting the dots together. There should be no connection between these extremes here. All right, so this over here should not be connected what's over here. They shouldn't be connected, and all those vertical lines shouldn't be there. So when I'm looking at this, my big question is, when does this function equal the number 4? Now, granted, if I was just looking at this and I was blindly looking, I'd say, oh, 1, 2, 3, 4, 5 times. But that's not true. It's hitting it 1. It doesn't hit it here. There's no line there. So 1, 2, 3 times. It hits it 3 times. All right? So what I want to do is I want to go back over the notes. And I know it's tough to look back over it. And that's my better picture of it, by the way. But anyway, this problem over here, let's see, was this one. All right? And again, I got to be honest with you, it's not an easy question. All right? But what did we do over here? We computed it. All right? What did we do? We looked at this over here, and we made some computations over here. All right? So what do we do over there? I did in steps. All right. I also gave a better picture for it. And someone says, your picture doesn't look like the other picture. You're right. I did something different. All right. I did something different. What I do, I did the graph of y equals x cubed, and I did the graph of this over here. All right. So again, I realize a lot of students are looking at it saying, why those two? I just felt it was easier to look at this graph than the other. And I'm looking at this thing as being, 1. I see 1 point of intersection here, 2 and 3. I see 3 points of intersection. All right. So again, we did it by hand, and sometimes I like to use software to give me a better feeling for what's happening with these problems over here. This was a tough problem, though. Even by hand, it was tough. Using a machine doesn't make it easier for me. All right. It really doesn't make it any easier. But we were able to do that, and hopefully, if you watch the video and the presentation for that, that you're able to follow what we've done. All right. Let me go back to my my Sage. And we just finished this over here. All right? Thank you for paying attention, though.